Modern technologies can instantly recognize objects and living beings in real time, and this ability no longer surprises anyone nowadays. But how does it actually work? In this video, I'll describe the basics of object detection. What is it, how it helps computers to see the world around them, and the easiest steps to start using it with Raspberry Pi and AI camera. Object detection is a part of computer vision. It identifies and locates objects on the image or video. There are three main detection methods: region-based, single-shot, and transform-based. Let's review how they work, starting from the region-based. The region-based process is also called the sliding window method. It checks content inside a small part of the image and then shifts the window to the next position. If a part of the object or a whole object is in the position, the algorithm marks this area. Then it goes to the next position. If there are a few objects or features in the window, it marks both of them. It checks the whole image step by step. When the image is processed, the algorithm counts the amount of parts and groups them into objects. As a result, there will be boxes with classes of detected objects. This example isn't quite precise. In real applications, the sliding window will be smaller, and the results will be better and look like this. This method is highly accurate and works well in most cases. On the flip side, it's a demanding process. It does a lot of computations and has a relatively slow speed. Let's move on to the single-shot method. In this detection process, the image is divided into a grid, and all the cells are processed at once. As a result, there will be similar boxes with classes of detected objects. The method is quick and less demanding. It's more suitable for the edge devices like Raspberry Pi. However, I'm not completely right about this picture. If the objects overlap is too intense, some cars may be missed or grouped into one object. Last but not least, transform-based detection method. This type of network determines far more information about a picture than the previous two types. It captures complex spatial relationships and the global context of the image, then wraps the results in bounding boxes and returns them. It's the most precise method of object detection. However, like anything, it comes at a price. It's the most resource demanding. There is no universal network that is best for everything. Each of these models is suited to different situations and tasks. Usually single-shot models are better for real-time object detection. They are significantly faster on edge devices. Let's review how to use them on a Raspberry Pi with AI camera. First, I will use Raspberry Pi Imager to install a standard Debian operation system onto the SD card. Then I will connect to the Raspberry Pi via SSH and clone a repository with installation and detection scripts. The link to it is in the description of this video. After that, I must run git submodule init and git submodule update to download models. Oops, I forgot to change the folder, I must be in the repository. Next I will run the install.sh script, which will install all dependencies and reboot the device. When the setup is done, I can reconnect to the board. The repository has a file, recognition.py, with all the needed code for real-time object detection. It's a modified copy of an official example from the Raspberry Pi developers. Let's run it and see what it does. The script detects a person and draws a bounding box around me. Now let's break down the code line by line. All the magic happens at the bottom of the script, on the line if the name is main. There are a few lines to print logs, I will skip them and describe only the important ones. The script starts by defining the models. There you can see some familiar names. Only one will be used so that the rest will be commented out. Then I create an object of a specific device and pass the model as an argument. In my case, the device is Sony IMX500. The next few lines are the definition of network settings. Then I create an object of a camera and a preview settings. Here I can tune some controls, but it could be empty for now. The Python script uploads the model to the camera. The first line shows the progress bar when it happens. The second starts the recognition process. From that point, the AI camera will capture and recognize images while the script is running. The pre-callback method is used to draw bounding boxes on the picture from the camera, like this. Finally, we have reached the most essential part. In this infinite loop, I received the recognition results. The capture metadata method retrieved the current state of the camera, providing a large JSON with many parameters. Here is an example of what we received from it. Then I feed this metadata to the parse detection method, which returns a simplified JSON. As you can see, it's an array of objects, each representing a bounding box. The box field indicates where the object is located in the image. Category specifies what the object is. For example, in labels.json, 0 or the first position corresponds to a person. And that was the case for me. Last but not least, the confidence field shows how certain the model is about detection, with a value between 0 and 1. The final lines in the script simply print the detection results to the console. That's it! With understanding of how it works, anyone can build their own project using Raspberry Pi and AI camera. If you found this video useful, like, share and subscribe. Thanks for watching. Cheers!